Okay, so solving word problems when it comes to trigonometry. What are the steps? What should I do? And how do I know which one am I using, right? Because in the question, it's not going to ask you use sine law to solve the problem, right? It's not going to tell you to use trigonometry. You have to kind of know which one you're using. Are you using trigonometry? Are you using sine law? Are you using cosine? So first of all, you have to state the given information and draw a picture. Okay? So state given information. And draw a picture. So you're going to choose the appropriate method, right? The appropriate law. If it's SOHCAHTOA law or if it's sine law or cosine law. So the appropriate method to solve the problem. Sometimes you have to use more than one law or more than one trigonometric ratio to be able to solve your problem, right? You've seen some questions like that. For right angle triangle, what do I use? SOHCAHTOA. Yeah, so the primary trig ratios and or the Pythagorean theorem, right? Remember that if I have two sides, if I know two sides, A and B, let's say, and I'm looking for C, right? I can use the Pythagorean theorem. A squared plus B squared equals C squared. That's the only method I can use to solve for my third side. Okay, remember that? Okay, and that can only be used in right angle triangle. So you can use the primary trig ratios. And Pythagorean theorem.
Second one is method?
Yeah. Is there an E for method?
No, METHOD.
What's this name? The other one?
Pythagorean theorem. But I did introduce that.
Yeah.
I did introduce that to you. Yeah.
And which formula is this?
What?
So we know the SOHCAHTOA, right? And what is the other one? This whatever.
Pythagorean theorem?
Yeah, whatever. What formula is this? Like which formula is this? Yeah, I forgot.
That's like slope, right? No? But why would we use that?
To find a side if you're given two sides. There's no other way in the right triangle. In the right triangle, there is no other way to solve a third side if you're only given two sides other than the Pythagorean theorem, right? And that C is always your hypotenuse, right? And remember, I told you that if you're looking for A, for example, it's going to be A squared. I guess I just want this. A squared equals to C squared minus B squared. Or if you're looking for B, it's going to be B squared equals C squared minus A squared. Well, trigonometry is geometry. It's a triangle. Trigonometry is the geometry of the triangle. That's what trigonometry is. And go back to your notes. Go back at the beginning of this unit. I did explain this. I did explain it on day 1 of our lesson as well. If you go back. And I did mention this. It's not the first time that you see it with me. right? I said it somewhere. I don't remember when, but I did teach it. First day of school. Okay. So, for triangles, what are the laws that I can use? Sine law and cosine. Now, let's look at the, before I write, let's look at what are the options so I know which one I'm gonna have to write here. So when I have one pair of opposite side and angle must be given plus one more piece. So I have an angle and its opposite side. What law is that? Sine law. Because you need to have an angle and its opposite side, right? And then it says here, the third side can be found from subtracting two angles from 180, the third angle, we should say. Okay, so the sine law right? And what is the sine law? What's the formula for it? What's the formula for sine law? What's the other one? Now, when do I use the first one? Sine A over A, cosine B over B, cosine C over C. When I'm looking for an angle. When do I use the second one? When I'm looking for a sine.
So the
Now-
first one you use for sides and second one for angles, right?
No.
Oh, the opposite of that.
This one you're using it when you're looking for an angle. This
Yeah.
one you're using it when you're looking for a sine. What law do you use when you have two sides and a contained angle, or when you have all three sides?
Cosine.
Cosine. I'm gonna write the formulas next to the case. So for this one, you're looking for the side, so you're gonna use this formula. And it's different versions, but I'm gonna write one of them. And then when you have three sides and then you're looking for an angle, you're gonna use this one. All right. You know what's the number one mistake when this happens? Students look at a triangle, they don't even think if it's a right angle triangle or not. You have to ask yourself the question, is it a right angle triangle? If it is, then you're gonna have to go to the SOHCAHTOA or Pythagorean theorem. If it is not, then you're gonna have to go to the sine law and the cosine. Okay? First thing you're gonna look at, what kind of triangle do I have? Do not ever use SOHCAHTOA for not right angle triangle because the answer is wrong. I won't be giving you even part marks. Because where's your hypotenuse? Huh? You won't have a hypotenuse. You guys see what I'm trying to say here? So please look at your triangle and see if it's right angle triangle, then this is when you're gonna go to SOHCAHTOA and Pythagorean theorem. And don't use sine law and cosine law with Pythagorean with the right angle triangle. Because then you're making it harder for yourself. Okay? Now, after you decide what law to use, okay, then you're gonna solve for the missing variable. Make sure you understand what the question is asking you for, what I'm trying to solve for. Make sure the answer is, I don't know what I'm trying to say. When you're writing your answers, I'm always looking for your for the correct what is it called? The correct rounding. Okay? So make sure that you're also rounding properly. What do I round sides to? What do I round sides to? To the nearest tenth, so to 1 decimal place. What do I round the angles to? Angles. Whole number. Okay? And trig ratios to 4 decimal place. So make sure the answer, I don't know what I'm trying to say, fits in the context of the question. Let's go with that. And then write a final therefore statement. Let me just, you guys don't want to lose marks, right? For not writing a therefore statement. Okay. Let's read that question. From the top of the Niagara escarpment, one sees the car below at an angle of depression of 40 degrees. He is approximately 100 meters above the car. How far is the car from the base of the escarpment? Round your answer to the nearest meter. So, what do I have here? So this is where the escarpment is, right? This is where 1 is, right? And there is a car. Okay? So car is Juan's looking down to the car. The angle of depression is 30 degrees. So Juan is standing right here and he's looking down at the car. Where's the angle of depression? So where is the angle of depression?
At the top.
Right here?
Oh yeah, no, the opposite side.
I have to draw a horizontal line from where 1 is, and then the angle of depression is this. Remember that the angle of depression is measured from the horizontal down. So what would this angle be?
But say you figure out that angle and then subtract, because if it's horizontal, it's gonna be 90 degrees, right?
Mhm.
You could do it that way too.
Yeah, so this is 90, right? And this is 30, so what would this be?
60.
Good. So this is 6. Okay? Now, one is 100 meter above the car. So which side is the 100 meter?
No, wait a minute, that's not 30, it's 40.
Does it say 40? Okay. Sorry, I don't know where. So this
Yeah.
is 40, then this is 50,
50.
right? Good. Okay. So he is 100 meter above the car. So what side is that? J to A? Right? Because if the car is driving, the car is going to be driving this way, right? So it doesn't matter if it's like from here to here or from here to here, it's 100 meters, right? So this is going to be the 100 meter. Okay? Because you're talking about vertical distance. He's above the car. What kind of angle is this?